In this video, we are going to be doing some practice specific heat problems where our specific heat equation is Q equals mc delta T. So we're going to define what all these variables are first. So Q is for heat, and we measure heat in joules. And this can be positive if it's absorbing heat or negative if it's releasing heat. M is our mass, and we're going to be measuring our mass in grams. Mass is always going to be positive. C stands for our specific heat. Our units for that are going to be joules over grams times degrees Celsius, and will always be positive. And then our delta T is our change in temperature, okay? Where this is our final temperature minus our initial temperature. And that change in temperature is what we're going to use. So this can be positive if the temperature went up, or it can be negative if the temperature went down, meaning it cooled down. Okay, so as we read through each one, we're going to annotate our questions by underlining what we are given and circling what we want and figuring out what our variables are. Then we're going to rearrange the equation and plug in our values to solve for what's missing. So here we go. Number one, a sample of water absorbs 3,420 joules. Okay, stop. This one we're given, it says absorbs this many joules of heat. That tells me that this is Q. So above it, I'm going to write Q. So I know that that's this variable. And I'm also going to write positive because I'm absorbing heat, okay? Of heat as it warms from 25 degrees Celsius to 35 degrees Celsius. Okay, so I'm going to stop and underline these two because the degrees Celsius is telling me that it's my temperature, because we're going to measure our change in temperature in degrees Celsius. So the T final is going to be where I ended up, and the T initial is where I start. So 25 to 35. That's what I'm going to use to find delta T. If the specific heat of water is 4.184 joules over grams times degrees Celsius, okay, stop. This I'm going to underline, and I know that this is C, specific heat, for two reasons. One, it says the specific heat of, and two, the units are the same as specific heat. So continuing then, what is the mass of the water? So I'm going to circle mass because that's what I'm looking for, and above it I'm going to write M because that's the one that I don't know. So I'm going to list my variables out. Q equals M C delta T. So I'm going to plug in what I've got to keep myself organized. So Q is 3,420 joules. The mass, we don't know, so I'm going to write a question mark. C for specific heat is 4.184 joules over grams times degrees Celsius. And then delta T. So that's my final temperature, which is 35, minus my initial temperature, which is 25. So this is 10 degrees Celsius as my delta T. Okay, so next, if I look at my equation, Q equals mc delta T. I'm going to rearrange this so I isolate the M variable. So since I'm multiplying mass times C times delta T, I'm going to do the inverse operation and divide out the two that I don't want next to mass. So I'm going to divide out C for specific heat and delta T on both sides. So if I do this, then C and C cancel. Delta T and delta T cancel. So if I rewrite this, I'm going to have my mass equals Q specific heat, or Q, joules, divided by specific heat and delta T. So now that I have this rearranged, I'm going to plug in my values, where mass is going to equal the Q, which I identified as 3,420 joules, divided by the specific heat, which is 4.184 joules over grams times degrees Celsius, and delta T, which I subtracted to find as 10 degrees Celsius. So let's take a look at units and then we'll plug it in the calculator. Joules over joules cancel, and then degrees Celsius over degrees Celsius cancel. And what we end up as, or excuse me, what we end up with is 1/1 grams, which flips to the top, okay? So when I put this in the calculator, here we go. 3,420 divided by 4.184. Now right here, a lot of students will want to hit multiply. Unless you put the denominator in parentheses, it's going to multiply the 10 by the first number you put in. So to make it easy on yourself, just hit the divide button again. So then divided by 10. So our answer, and we're going to go to the second decimal place or the hundredths place, is 81.74. And the only units we have left are grams. And this makes sense because we're looking for a mass. Okay, here we go. Next question. All right, so let's see what we got. Number 2, a 55.0 gram. Okay, stop. The gram, I'm going to underline it. The gram tells me that this is a mass because those are the units of mass. Of unknown metal, cools from 95 degrees Celsius to 30 degrees Celsius. Okay, so the 95 and the 30 degrees Celsius tells me the temperature. So if it's going from and then to, I know that this is my initial temperature and this is my final temperature. Now, yes, the final is lower than the initial because it's cooling down, okay? While releasing 1,430 joules of energy. So the joules I know is going to be Q because of the units and it says of energy, but it's releasing energy. So since it's releasing, I'm going to use a negative to indicate that this is going to be a negative value. So what is the specific heat? So I'm going to circle that of the metal. So the specific heat is the C. So we know that we're looking for C. So we're going to do the same thing again. Q equals MC and delta T to lay it all out. So Q is a negative 1,430 joules because it's releasing that energy. The mass is 55.0 grams. The specific heat we don't know. That's why we circled it. And our delta T is our final temperature, so 30 degrees Celsius minus initial 95 degrees Celsius. So 30 minus 95 is negative 65 degrees Celsius. So this is our delta T. And this makes sense because it's cooling down. So our temperature is going down, so we have a negative value. Okay, so let's rearrange our equation. Q equals M C delta T. And I'm trying to get the C by itself or isolate that variable. So because M and delta T are being multiplied by C, I'm going to do the inverse operation and divide out the M and the delta T on both sides. So if I do that, the delta T's cancel and the M's cancel. So what I'm left with, oh my goodness, excuse me, is C equals Q divided by M delta T. So now I'm going to plug my values in. So C specific heat is going to equal my negative 1430 joules divided by my mass, which is 55 grams, 0.0 grams, but the 0.0 we can leave off for now, and divided by delta T, which I found to be negative 65 degrees Celsius. Now, none of these units cancel, okay? So we can't cancel any of them because we know that our units of specific heat are joules over grams times degrees Celsius. So that means we're looking pretty good to solve. So I'm going to plug this in my calculator. The negative button is down here at the bottom. This is for subtraction. So this one is the one we want to use when we have a negative. So negative 1,430 divided by 55. And then I'm just going to hit the divide button again. Divided by 65. So this gets me 0.4. And since none of my units cancel, they're all included in the answer. So 0.4 joules over grams degrees Celsius. Okay, let's look at the next one, number 3. A 250.5 gram, okay, stop. This 250 gram is a mass, and we know that because of the units of gram. Block of aluminum is heated from 22 degrees Celsius to 65 degrees Celsius. Okay, so I'm going to underline the 22 and underline the 65, and I know I'm going to use this for delta T. So the 65 is the final because that's where I'm ending, and the 22 is the initial. And that also makes sense that our final is higher, because we're heating it up. So how much heat energy? Okay, so heat energy, we're looking for then Q. We're looking for Q, and it's absorbed, so we're going to end up, we know, with a positive Q. If the specific heat of aluminum is 0.897 joules over gram degree Celsius. And I know this is going to be C, specific heat, for two reasons. One, it says the specific heat of, and number two, the units match specific heat. So here we go. Q equals MC delta T. The Q is the one we don't know. We do know it's going to be positive, but that's the one we're solving for. Our mass is 250.5 grams. Our specific heat is 0.897 joules over grams times degrees Celsius. And then delta T is going to be our final, so 65 degrees Celsius minus the initial 22 degrees Celsius. And when I subtract these two, I'm going to get 43 degrees Celsius. So this is what we're using for delta T. So the equation Q equals MC delta T. I already have it set up where I'm solving for Q, which is what I want. So I don't have to rearrange anything. I can just plug in my numbers into this equation to solve for Q. So Q is going to equal my mass, 250.5 grams, times C, 0.897 joules over grams times degrees Celsius, times delta T, which is 43 degrees Celsius. So grams and grams cancel, degrees Celsius and degrees Celsius cancel. So now I can plug this in my calculator. So 250.5 times 0.897 times 43, because they're just being multiplied by each other, equals 9,662.04. And the only units we have left are joules. And it's 0.04 because this 5 is going to round this 3. So that's our answer. That's a lot of energy going in to raise the temperature of this aluminum block. Okay, last question for our practice. A 95.8 gram. Okay, stop. This is the mass. And we know this because it has the gram. Of ethanol releases 2,930 joules. Okay, so this we know is Q because it says joules of energy. But it also says it's releasing it and it's cooling down, which means my Q is going to be negative because we're releasing that energy. What is the temperature change of ethanol? Okay, so the temperature change means that I'm looking for delta T. I don't have an initial and a final. I'm just looking for that change in temperature. The specific heat is 2.44 joules over grams degrees Celsius. So we know this is going to be C because it says specific heat is and the units match specific heat. So Q equals M equals C equals delta T equals. Our Q is negative 2,930 joules. And I know it's negative because it's releasing and it's cooling down. Our mass is 95.8 grams. Our specific heat is 2.44 joules over grams times degrees Celsius. And then the delta T is the one we don't know because we're looking for that temperature change. So Q equals MC delta T. Now I'm going to try to get the delta T by itself. Okay, I'm going to isolate that variable because that's what I want to solve for. So since mass and specific heat and delta T are being multiplied together, I'm going to do the inverse operation and divide out the MC from both sides. So specific heat and mass cancel. So what I'm left with is delta T, or our change in temperature, is going to equal Q over MC. So now I can solve. So delta T, our change in temperature, equals our Q, which is a negative 2,930 joules, divided by the mass, which is 95.8 grams, and specific heat, 2.44 joules over grams times degrees Celsius. Okay, so let's look at the units. The joules and the joules cancel. The grams over grams cancel, and I'm left with 1 over degrees Celsius, which flips to the top. So let's put this in the calculator. Negative, and again, make sure that you're using the negative button, 2,930 divided by 95.8 divided by 2.44 equals negative 12.53, and our units are degrees Celsius because it's a temperature. So that means that for this sample of ethanol, the temperature went down by 12.53 degrees Celsius. So it doesn't really matter where it started and where it ended. This is the change in that temperature, or the difference of that temperature. Okay, so here's some examples that we just went through for solving for specific heat and solving for each variable in this equation.